everyone, and thanks so much for joining us today. My name is Teresa, and I'll be moderating today's one-hour webinar, which is Crisis Management of Accidents and Navigation Hydraulic Structures, hosted by PIANC USA. And before we dive into today's topic, I'm going to take just a quick minute to familiarize folks with our webinar platform, which is WebEx. On the bottom of your screen, you'll have options to mute and unmute your line, raise and lower your hand, or send a reaction to interact non-verbally, and to access the chat panel. We will have a brief Q&A at the end of today's webinar, and we ask you to submit your questions throughout the webinar in the chat panel to be addressed at the end. If you'd like, we also ask folks to keep their video off during the presentation, but you can turn it on and hop on your microphone to ask a question during that Q&A session. All participants are eligible to earn 1 professional development hour for their attendance today. That certificate is available, and we'll share a password to access it at the end of today's webinar. And like I mentioned at the top, if you have to duck out early, a recording will be sent to you after it is posted to PIANC USA's YouTube channel. We'll send you a direct link so that you can take a look at it afterwards as well. Finally, I'll provide just a brief introduction to today's speaker, Timothy Paulus. Mr. Paulus was chairman of Working Group 241, which crafted the guidance that you'll hear about today. He's also participated as a chairman or member of numerous other PIANC working groups, and he served on numerous dam safety evaluation teams and periodic assessment consistency review teams in his role at the U.S. Army Corps of Engineers. As we get started today, I will note I do believe we have a lot of Army Corps of Engineers folks on the call today. USACE is a PIANC member, so if you are a USACE employee, you are eligible to all of the PIANC membership benefits. If you have any questions on that, feel free to email us at pianc@usace.army.mil. And with that, I will hand things off to Mr. Paulus to share his screen and take us through the presentation.
All righty, so let me put this in read mode here. How's that looking?
Great.
I can do it. Let me just do one thing here real quick. How's that? That's even better, right?
Even better.
Even better. There we go. Okay. Whoop. I want to go there. Okay. There we go. All right. Welcome, everybody. Thanks for joining today. My name is Tim Paulus. I work at headquarters. I've been at headquarters now for 4.5, coming up on 5 years already, actually, in September. So I don't know how time flies, but it does. I've been at USACE now for 37 years. It's kind of funny. When I started back in 1987, I'm dating myself here, but I used to think people that were here this long were like dinosaurs, and now here I am. But hopefully I'm not a dinosaur. So I do want to make, and I know Teresa mentioned this, but I got involved with PIANC back in 2010 on one of the working groups. It was a mechanical electrical working group. I didn't have a clue what PIANC was, so but it's a pretty valuable avenue to really learn a lot, work with a lot of people all over the world, really get involved in a lot of different things. You know, there's PIANC work groups on miter gates, for example. There's remote operation. There's a whole gamut of PIANC working groups. This happens to just be one of them. So I would encourage anybody that if you do get a chance to actually work and participate on one of these working groups, I know everybody's busy, got a million things going on, but if you really get a chance to do one of these, I would highly encourage it. All right. With that being said, here's our members of this particular working group, 241. This was published back in March of 2024, so just a few months ago. Richard Daniel, I don't know if Richard's on here or not. I can't quite see my participant list here anymore, but Richard is the chair. I guess I consider myself a co-chair. This particular working group, Richard and I, we wrote a book together, and this happened to be one chapter in that book, you know, this crisis management of accidents. So Richard took it upon himself to expand on this and make it an actual working group with PIANC. There's a terms of reference, you know, it's that has to be submitted and gets approved by PIANC. So Richard took care of a lot of that. So thank you, Richard. We had a representative from France, Yves, Linda from Germany, John Langman from the Panama Canal. I know Ellen is on here. He just retired from the St. Lawrence Seaway. Bart, I don't know if you're on here or not, but he was from Belgium. And then Professor Philip Brigot, he's our INCOM chair. He actually teaches in Liège, Belgium, but he's the INCOM chair. He helped review this and offered a lot of good insights also. So that's our group. This is very typical for PIANC working groups where you get a good mix from a lot of different countries. So this is, like I said, you get a chance to work with a lot of different people from a lot of different backgrounds. Okay. I'm sure you've all heard about the bridge collapse, the Francis Scott Key Bridge collapse in Baltimore Harbor. This particular working group, I think it was a week after this working group was published that this accident happened on March 26th. So a lot of the things that this working group covers is very relevant to this particular accident. And this photo was actually provided by the Baltimore district. It was from Mr. David Adams. He's the public affairs specialist in Baltimore district. One of the things that I didn't, that you don't really get from the news is you can't see the actual damage to the ship. You can see when it crashed into the concrete pier, it gashed a hole in the side of the ship, and then tragically there was 6 people working on the bridge that lost their lives when they fell into the water. Just in the last couple days, I think it was on Monday. So if you go on YouTube, you can actually see this ship being floated away. They had like 5 or 6, I think it was 6 towboats pushing this back into the harbor. So just within the last week, they were able to get the trusses off this bridge and get it back into the harbor. This ship is the Dolly, is what it is. And then the other thing you don't get a perspective on and how big this particular ship is. So here you can see that, the workers standing on top of some of the cargo containers. You get a sense of the scale, how big this ship is. And you can see the beams, on the front side of this. So like I said, if you go on YouTube, just type in Dolly, D-A-L-I, Dolly floating, back to the harbor or something like that, YouTube. But there's a bunch of YouTube videos of this actually being pushed back into the harbor. Okay. So we got a lot of engineers on here, and we got a lot of maintenance people and operations people. So, we're really good at engineers at designing things and, designing them to factors of safety and things like that. But one of the things that a lot of times we don't think about is, how do we handle failures, risk and things like that. And I know the Corps of Engineers, we've got our risk management center and things like that, and we do look at risk. But a lot of times when we're designing things, we don't really think about all the things that could happen out there. And there are a lot of failures. I'm going to show a bunch of that up front here. They happen a lot more than people think, for all different reasons. And then the cost of these accidents and failures are growing for a lot of different reasons. We've got a lot of demand on the waterway structures all over the world. This particular photo is at Terneuzen Lock in the Netherlands. This is a rolling gate that the ship hit in this particular photo. So again, these navigation accidents, this report, and I'll get into that in a minute here. We did classify accidents. We did, failures. A lot of times they result in the same thing, takes the lock or the navigation structure out of service. But they're very common. This particular photo that you see off to the right here, this is in Germany at the Iffensheim lock. That happened back in November 2023, and then I've got another slide coming up in France at the Newfoss Canal back in September 2023. Thanks to Mr. Dennis Meckers in the Mobile district, I've got a couple slides on the Demopolis lock in the United States. We had a failure of the miter gate seal on that particular lock back in January. Just in April, in the Pittsburgh district on the Ohio River. I don't know if anybody's on here from Pittsburgh district, and we can elaborate more on that in the chat, but a bunch of 26 barges actually broke loose. It closed the river to traffic. I think several of the barges hit a marina and destroyed a bunch of stuff. And I think some of these barges, they actually ended up, I think it was Emsworth Lock, is where these barges ended up on the dam. Okay. So that was another very recent accident. And then in February, there was a vessel collision with a railroad bridge in Germany over the River Hunte. This was a 110-meter inland vessel. It collided with the railroad bridge. So that's another recent accident. And then just actually within the last week, I don't know if anybody saw this on the news. We got anybody from the Galveston district here, but there was a barge that slammed into a railroad bridge piers in Galveston Harbor in Texas. Oil got spilled into the water. There was one person that was thrown into the water after the barge hit the bridge pier. He was rescued, fortunately, so nobody was injured or killed. But the tugboat backing out of the fuel storage area lost control of the two barges it was pushing. Okay, so that happened within the last week. Here's another photo of that ship impact on the Rhine River. This gate. So at the time they were fortunately this lock, it's got two lock chambers side by side, and they were actually working on the other lock chamber maintenance when this accident happened. As you can see here, it completely destroyed the lock gate. It actually darn near went over the lock gate. So what they were able to do was they had to obviously stop maintenance and things like that on the other lock chambers. So they diverted all traffic to the other lock chamber. Now, this happened back in November. I don't have, if someone's online here, my counterparts, if they've got an update on the repairs of this particular lock gate, I'd appreciate putting that in the chat. But again, this happened last fall. Okay. This is the Fontenet's lock in France. So here, if you can see off to the right here, the pilot actually had a green light. I can see if I can put my pointer on here. They actually had a green light to enter the lock chamber and move forward. So they did, but at the same time, the gate was closed. And then you can see some of the damage here that I got off to the right here. But the ship was allowed to enter the lock. It had a green light. Fortunately, the damage wasn't extensive, but it did caused some damage to the gate itself without any major deformation. Okay. This is the Timothy lock on the Tombigbee River in the United States. This is what I mentioned previously. So I know Mr. Meckers from the Mobile District was asking if there's any other locks that we've had out there, here in the United States or, in Germany or France or in Europe, where we've actually had a miter gate seal that actually blew out. But this happened back in January of 2024 on the Tombigbee River. So we actually had uncontrolled flow through this lock chamber for at least a few days here. And you can see the damage here, off to the right. I talked with Mr. Meckers, and Dennis, if you're on here, you can put some things in the chat. But just within the last 1 to 2 weeks, they were actually, I think they were actually able to get the lock back in operation. So they're back up and running now, as far as I know. So again, the key takeaways here is that, accidents and failures with our navigation structures happen a lot. They happen frequently. So one of the things that we tried to focus on in this working group report is crisis management plan. Making sure that these waterway organizations, like the Corps, but there's a lot of other waterway organizations throughout the world, making sure you have a crisis management plan, and it has to be adapted. It's a continuous cycle, trying to keep this up to date. The other thing that when we're writing this report is, there seems to be a real definite need for more guidance on this entire issue. How do we adequately manage these navigation accidents and failures? So I think this working group report is certainly a step in that regard. Okay. This picture that you see off to the right here, this was taken by Jim Ulrich in the St. Paul district, but this would happen at Lock 5A up in the St. Paul district on the Mississippi River. We had a barge that actually ran into this gate. Fortunately, they were able to swap out gates, so this lock wasn't out of operation real long, okay? But you can see the damage to the miter gate here. A couple key takeaways. So accidents and failures to our hydraulic structures, like lock gates and things like that, happen not only when their loads exceed the design strengths, their causes are, lack of inspection, maintenance, improper. We're going to show a lot of coming up here on the case studies, improper operation, sometimes navigation errors. We can get extreme weather events, fog, for instance, that happened in the Netherlands. And we'll show that in a minute here too. There's a couple of these case studies that we looked at that the ship, they tried to stop the ship, and instead of stopping the ship sped up. So it could be something like that. There are often combinations and really complex sequences of events that can lead to accidents. That's another thing that we noticed. This picture that you see off to the right here is from the Smith & Lock. And Mr. Bob Petit provided that one. This actually crashed into one of our lock gates. So you can see the damage to the barge here. So Bob, if you're on, if you want to provide any more information on that in the chat, that would be great. So this is our report. We got 7 chapters altogether. The first chapter is just introduction, introduction to our members and things like that, and what we're trying to do here. But the second chapter, we tried to get into, how do we classify accidents and failures, looking at the context. We've got a bunch of case studies. We got 16 altogether. I'll show those in a minute here. But we tried to summarize each of those case studies. In this PIANC Working Group report, we've got one PDF that, that has the report itself, and then we've got a separate PDF, that actually has all 16 of these case studies. I think it's like 130 pages. So if anybody's going to want this report, you're definitely going to want both of those documents. Chapter 4, we tried to identify and reduce, ways that we can reduce risk. Chapter 5, how do we investigate accidents? What are some of the ways that we do that, in these different waterway organizations? Chapter 6, we looked at life safety risk. And Chapter 7, we, how do we recover from the damage? What are some good lessons learned? Okay. So Chapter 2, it gets hard sometimes putting actual definitions on these, but we looked at failures. And you can see some of the definitions there. We looked at accidents, and then we also looked at calamities. So, we considered a calamity probably the worst case scenario. So, there's several definitions that we had in this working group report, but certainly any time that we lose a life, that certainly rises to that level. And tragically, on that Baltimore, the Francis Scott Key Bridge, we lost 6 lives in there. I've got coming up here, I'll show a couple other examples where, we've actually had life loss. We did also, in this report, we looked at, we called it regular demand, but that's our normal maintenance and normal contracting procedures and stuff like this. A lot of times when we get into these accidents and failures, we've got a crisis situation and we've got to bypass a lot of our normal contracting rules. In USACE, and I know this definition, we try to look at this a lot, but we look at, if our lock cannot pass traffic for 4 hours. I think the key takeaway here is that, all these waterway organizations, whether it be the Corps of Engineers, that we actually have a really good definition of a failure. It doesn't have to be 4 hours. It could, it could be 8 hours, whatever it is. It's important to actually have a definition out there. Okay. So a failure can have major consequences, like but it could certainly take the lock out of a race. But sometimes, we can get a failure, but things keep working. For example, if we've got a computer controlled PLC, a programmable logical controller lock, if we got a failed computer chip, all of a sudden our signal lights aren't working properly, and it could slow down traffic. We can get our machinery. We got issues with the machinery that reduces the speed, for instance, let's say on the miter gate. For whatever reason, we can't operate on high speed. We got to be on slow speed. It slows the locking process. We can still lock both, but a lot of times, our blocking might double. We can get a culvert valve that stops working, but if we got redundant culvert valves, we can still fill and empty the lock chamber, but sometimes, our filling and emptying could be doubled, okay? We get a lot of, so one of the things we looked at in this report, we get a lot of multiple accidents and failures that can happen, like we saw just previously here on these slides, but barge and ship collisions are certainly one of them. A lot of times these are low speed, but sometimes they can be high speed. The one that you saw there in Germany, that, I've got another one coming up here on the Kiel Canal in Germany. That was actually a high speed collision. We can get gate structural failures, our connections and our anchorage failures. We can get mechanical, electrical failures of our drive machinery. We get interlock failures. I'm going to talk about the Markland lock in the United States. We had interlock failure there. We lost a miter gate. Electrical power, certainly that's something we try to look at in the Corps, is whether we need backup power at these locks and things like that. Vessel accidents, okay? So our case studies, we had 16 case studies, and you can see them here. I'm going to highlight a few of these toward the end of this presentation, but you can see we tried to, cover a wide range of things here. We've got on the Meuse River in the Netherlands, we've got a couple of them. Here's the Markland one, the Sablons lock. Like I said, we've got a really good, I think this is like I said, like 130 pages, but we went into a lot of depth on each one of these case studies. We looked at what happened, how it happened, how did you recover from the damage, if there was a board of investigation, what sort of accident investigation occurred, what are some of the lessons learned. So each one of these gets into all those topics, okay? I'll just leave this up here just for a minute for everybody to look at this. Okay. And then in chapter 4, we tried to get into a lot of discussion on how we can identify and reduce risk. Interlock failures are certainly a big one. We got to make sure that, if we're opening gates, that we don't have flow through the lock chamber and our culvert valves are closed and things like that. Barge and ship impacts. I'm not going to read all the list here, but equipment malfunction, weather. A lot of times fog can be an issue. I'm going to talk a little bit about the Grave in Weer in the Netherlands. That was a fog issue, part of it. If we get excessive ice or debris, so ship maintenance issues, there's a couple of them I'm going to talk about on that, okay? So one of the things that the Corps of Engineers does, and I know probably a lot of you have been involved in these risk assessments that we do in the Corps, but on a periodic basis, and I think it's still 5 years, but somebody can correct me if I'm wrong on that, but we try to do a risk assessment on all our navigation sites, our locks and our dams, looking at potential failure modes that could lead to accidents and closures. And then I put and if I'm wrong on this, someone can help me here, but we define that failure as an uncontrolled, potentially life-threatening release of a reservoir and loss of a navigation pool greater than 4 hours again. Okay. So I guess the takeaway here is that, again, we want, whether it be in the United States for the Corps or, in Germany or the Netherlands, that, our recommendation here in this report is to make sure we do a risk assessment, look at all the different things that could happen at these lock sites and navigation sites. Chapter 5, we looked at investigation of accidents, looked at all the, the ways, the various ways that these waterway administrations are looking at investigations. Thanks to Bart here, I forgot to mention earlier with our, Bart Bommelin, he presented this working group at the World Congress in South Africa, I think about 3 weeks ago, I believe. So I stole some of his slides, so I should probably give him credit for some of this, but you can see what some of the takeaways for a good investigation policy. We want to make sure that, if there's things that we can do, to correct this in the future so it doesn't happen again. That's a really, really big takeaway, so that whether it's a board of investigation or whatever, that we make some very specific recommendations to make sure that this accident's not going to happen again. Okay. And again, our case studies that we put together, we tried to address a lot of the things that you see here. We tried to summarize that. Okay. Accident boards, the Corps of Engineers, depending on the severity of the accident and the dollar figure, we do have accident boards. I know the Panama Canal does. There's other waterway organizations that have accident boards, but this is a frequently used tool. In the United States, the National Transportation Safety Board also investigates navigation accidents. If you go on to the National Transportation Safety Board website, these are all public documents. You can actually, there's a lot of them that are navigation accidents. Some, they just do a really quick summary. I'm going to show a Sioux Locks accident on the pier. They did a very, very detailed investigation of that particular accident. And the Baltimore Harbor, the Francis Scott Key Bridge, they're certainly going to be involved in that. But anyway, those are all public documents that you can go on and actually look at. And if you just scroll down, you can see a lot of them that relate to, to waterways and to waterway navigation. Here's the Panama Canal Accident Board. Okay, and I don't know if John Langman's on, but he could probably elaborate more in the chat. But the Panama Canal, they do have a local inspector board. They investigate all the accidents. Okay, and you can see the different things, and whether it's a grounding or collision of vessels. I'm going to show a couple accidents on the Panama Canal. They had an oil spill. They had a ship collision. They'll certainly investigate things like that. Okay. Teresa, how are we doing on time? I can't quite see my clock here with this on. Doing okay?
We're right at the halfway point.
Okay. Life safety risk. The slide that you see off to the right here, this was at Montgomery Dam back in 2005. This was an upbound push tow, and there was really high water levels. And when they came out of the lock chamber, the current actually pulled the barges in the tow, into the dam. They lost control, that you can see here, and tragically there was 4 people that lost their lives in this particular accident. So we did look at life safety risk in chapter 6, but the bottom line is, we in this report, and we got to hold life safety as paramount. And then chapter 7, we looked at recovery from the damage. Okay. Regaining control, that's very critical at the first stages of this after an accident. Looking at investigation, looking at how do we rebuild, and then testing and commissioning it. And so this fish diagram is something that Richard Daniel developed in our book that we wrote together. So we carried that forward into this particular working group report. Okay. So again, urgency to act, immediately after the accident, we got to get control of the situation. But a lot of times we don't have the equipment and the manpower, at that time, right? So, I mean, these accidents happen, and there's a really, really high urgency to get stuff fixed, and get stuff under control. And a lot of times we don't have the equipment and the personnel to do that, okay? For repairs, depending on the level of damage and things like that, USACE, in the Corps of Engineers, we rely a lot on our in-house work. We got some really, really good people at our locks and dams that could do a lot of different work. But it's, I'm going to show a couple examples here, but sometimes we have to go to outside contractors. Conclusions and recommendations. So again, we try to recommend, best practice toward responding to these navigation accidents. And again, major takeaway here is that these navigations, accidents, and failures, they happen a lot. Again, a lot more than people think. And a few more key takeaways here. Every navigation site should really have a good continuous monitoring system in place. Making sure, the other couple of takeaways here, provide a database that records and tracks accidents and failures. I know we try to do that in the Corps. And then we want to make sure that we've got a risk prevention policy implemented at all our navigation structures. Like I said, I know the Corps of Engineers looks at the risk, on our navigation sites on a periodic basis. And it's really important to look at all the things that could happen. So the case studies, I'm just going to highlight a few of those. I'm not going to show all of them here, but I'll discuss more about the Kiel Canal here in a minute. But these are in Germany. So here's a couple on, that we had in our report on the Meuse River. The one on the left, the lift weir gate failure. Let's scroll to my notes here. Bear with me 1 second here, but this is managed by the Rijkswaterstaat in the Netherlands. This happened back in January of 2007. The top flap section actually broke off from the hoisting chain. This Meuse River is one of the highly traveled waterways in Europe, so it really posed a big threat to navigation. There was really high water levels also at the time. So when that flap was damaged, it actually damaged the main structural beams. It destroyed the chains on that. And I have another picture here in a second. The one on the right, that's the ship collision with the Grave weir. That was actually a benzene tanker. This was fog at the time. That benzene tanker was going at full speed. It actually went right through the weir. So this weir is actually a bridge weir. It's one of the unique structures in the world, but it was fog. It was dense fog at the time. So that benzene tanker actually went right through the weir. Fortunately, there was no leakage or anything like that. So you can see on the right here, the Grave weir, they had to put a temporary rock dam in there to close that off to fix it. And then on the left there, you can see the lift weight. They pulled the flap section out. As part of that work at the lift weir, they also had to repair the. And Richard, if you're on, you can elaborate more on that in the chat. But they installed new chains. They have a lubrication means now for the chains also that they added at the time. So this was at the Corps of Engineers lock at Markland. So this happened, excuse me, just 1 second here. This particular, just bear with me 1 second. I'm just looking at my notes here. Yeah, so this happened back in September of 2009, and this was in Louisville District. One of the, they had a board of investigation report on this one. If anybody wants anything like that, they can certainly reach out to me. What they had flow in the lock chamber when they were trying to close the miter gate. So one of the hydraulic valves wasn't totally closed, so the culvert valve wasn't closed. There was actually a cruise ship in this, the Princess, that was actually in the lock chamber at the time that this happened, and I think it actually snapped the mooring line. So they're lucky that that cruise ship didn't capsize, but it actually snapped the miter gate right off its hinge. And the miter gate itself ended up at the bottom of the lock chamber. Here you can see some more of the damage. Okay. This lock chamber was out for 155 days. They did have an auxiliary chamber, but it was, it wasn't a 1,200-foot chamber. It was a 600-foot chamber. So it really had a large impact to the navigation traffic. It doubled the lock, because they had to break the toes apart to get them through the lock chamber. John Day Lock out on the Columbia River. This happened back in 2008. So actually in February of 2008. All told, there was about $10 million in damage here. There was a barge in the lock chamber, and the mooring line snapped. And that barge actually went underneath the upstream vertical lift gate and actually lifted it out of its channel, if you will, and you can see it ended up on the wall here. But when that happened, it actually snapped, or actually broke the lifting chains, and then the counterweights. This has a counterweight on it, and the counterweights actually dropped, and you can see some of the damage to the shiv here. There was extensive damage here at John Day. One of the things that they did is they actually they worked around the clock to actually get a floating bulkhead to replace the gate. So they actually were able to get this lock back into service fairly quickly using that floating bulkhead. Okay. That barge that actually went under here, that actually was a diesel fuel barge. They didn't have any leakage of oil, fortunately, but their lockage time went from about 20. This is a really high lock. It's a 30-meter lift. Their lockage time went from about 20 minutes to 1 hour. Okay. The one on the left there, that actually should be 2020, not 2018. So there's a couple different collisions, but I'll talk a little bit about the one on the right here, back in 2018. That particular ship that actually hit that gate, it destroyed the gate. And so this is a really heavily used canal, the Kiel Canal, 27,000 vessels a year. So it's probably one of the most heavily used waterways in the world, actually. So the lock gate was destroyed. So what happened was the pilot, they were actually trying to slow down. Instead of slowing down, they were actually speeding up. And so what happened was the ship propeller, the hub of the pitch propeller had a failure in it. So they were actually trying to slow the ship down, and they couldn't slow it down. They were trying to adjust the pitch and doing all sorts of different things. They actually dropped the anchor to try to slow the ship down, and it snapped the lines for the anchors. So they rammed into this gate at full speed. Okay. It took 2 years to repair the gate. They actually had a 2-month shutdown, so they were actually able to swap out gates. Okay, but the gate itself, it took, I think it was 2 years. So Linda, if you're on, you can elaborate more in the chat. The Panama Canal, we had a couple case studies on there. The one on the left, that's a crude oil spill. What happened there was they were coming into the lock chamber. This particular ship, actually, at the Miguel locks on the old Panama Canal, the 2014 locks. This is a single hull ship, and they actually had leakage through that hull. They did a pretty in-depth investigative report. But actually, you can see some of the oil here in the water. But this was right at the entrance to the lock. This one on the right here, 2 of the ships, they had a collision in the Gatun Lake. One of the ships, it had uncontrolled. It was an issue with the ship where it actually went starboard and actually crashed into the other ship in Gatun Lake. Okay. The Welland Canal, this happened, and Ellen, I know you're on here. You can put some stuff in the chat if you want, but this happened back in 1985. You can see some of the photos here. So this was an issue with the penstock. The penstock was actually leaking behind the wall. And Ellen, you can, like I said, you can put some stuff in the chat if you want to elaborate on this. The penstock had extensive leaking behind the wall, so the wall actually failed, and you can see some of the photos here. The canal was closed for 24 days after this particular accident. But this was Lock 7 on the Welland Canal. A couple up at the Sioux locks here. The one on the left, that was actually back in 1909. So these accidents, they had a ship that was tied up just on the downstream side of the gate, and we did a pretty good job of working with Parks Canada and actually got quite a bit of information on this particular accident. But that ship broke loose and crashed into the lower gate and took out the miter gate. Well, once that happened, the upper gates were already open. So this was actually like a waterfall coming through this lock. They actually, at this particular site, and it's still there, if you ever get up to the Sioux locks, there's actually an emergency dam. It looks like a bridge. But they were able to set this and actually stop the flow through here. But that bridge is still there. Not a bridge, but a dam, an emergency dam, if you will. It looks like a bridge. And then the one on the right here, this was back in 2020. This was fortunately, this hit the guide wall and not the gate here at the pole lock. Here, I'll pull to the next slide here, but what happened here is here, I'll go to the next slide. And you can read it there. So this was a really, really in-depth report that the National Transportation, and you can see that they did here. And so this was an issue with the set screw, if you will, on the pitch system for the ship. So they actually tried to slow down as they were coming into the lock chamber. Instead of slowing down, it was actually the speed, it was doing the opposite. It was actually increasing. So like you saw in the kill canal, they tried to drop the anchor and slow the ship down. That worked a little bit, but they ended up crashing into the guide wall. I think the total damage here was on the order. I don't have the number right in front of me here, but it was several $1 million to, of damage that this caused. And you can see some of the damage on the, on the ship here, but this actually hit the west center pier at the Sulaks. Okay. Fortunately, no one was injured. There was no oil or anything leaked into the water. And like I said, they use ship arresters at this particular lock, but they never ran into the gate itself. So with that, that's a really quick snapshot, if you will, of our report, our 241 report. And like I said, I didn't get into a super amount of detail on all the parts and pieces of the report, but I thought I, provide, a little snapshot of some of the case studies that we looked at, and like I said, a big takeaway is these accidents happen a lot. And I'm going to stop sharing. See how we're doing. Yeah, we're about perfect for time here. So, Teresa, I think that's all I had.
Okay, that's great. And we are going to move into a Q&A portion. If you would like to submit a question, feel free to do so in the chat panel. I'm going to pull my chat panel now so I have that as well. We've received a number of questions during our presentation, so let's start there. First question is, a lot of these accidents are due to human error. And what are the issues that you've seen with emerging vessel automation?
Well, I don't know if I can answer that. I don't know if anybody on here from the Corps of Engineers can help me answer that. I don't think we've got a lot of vessel automation. Automation. I'm losing it here. That I don't know. If anybody can help me out that's online here on that particular question, or put it in the chat, or open up your mic. I do know that the Corps of Engineers, it's not necessarily vessel automation. They're looking at more in, this is certainly in Europe, that remote operation at their locks and things like that. But that I don't know the answer to that question.
Okay. Okay, we'll punt. And again, if folks have input, they can drop that into the chat panel.
Yes,
we received a few questions on information sharing. When accidents occur, do different authorities share their studies, such as the National Transportation Safety Board? And do you coordinate or share information with the Association of State Dam Safety Officers, ASDSO?
I do know that the National Transportation Safety Board, like I mentioned, those are public documents, and you can go online. If you just type in United States National Transportation Safety Board reports, you can bring up all the reports, but those are all public documents. And as for sharing with state officials, I don't think so. I do know that the Corps of Engineers, if the accident is, severe enough, there are Board of Investigation reports. And I think someone will have to help me if those are public documents or not, or we keep those closed hold. I think they're public documents, but I'm not sure. But somebody can help me out there.
Okay, we'll keep an eye out on the chat panel for more information there. And one question here, in looking at a risk analysis, it's often a function of probability of occurrence and impact, or the cost of the incident. Do you have any suggestions on how to quantify these parameters and any data that might be available to help? This person is working to conduct a risk analysis of a vessel fire in a lock chamber and the impact to the lock hydraulic steel structures.
Yep. I can put you in touch with our, we do these risk analysis at our locks. Just reach out to me, and I can put you in touch with a few people that are a lot smarter than I am when it comes to that. But yes, we do have dollar figures and things like that for all of that, depending on the lock itself. I don't know if Bob Petit's on here that could help me out here too, but but yes, we do have numbers for all of that, that we can actually look at the risk, we can look at the cost, and things like that. So yes, I can put you, if you want to reach out to me directly, I'd be willing to help you out with that and put you in touch with the right people.
Okay. And that question was from Blaine, who's raised their hand. Blaine, okay, looks like he will be reaching out to you shortly.
Okay.
Okay. Are there minimum accident insurance protocols for the owners of structures versus the ship owners?
Yeah, let me look at that question here. Hold on.
And I'll chat this one to you directly,
Yeah, I see Blaine Parkinson was the one that asked the question about the risk analysis. So Blaine, I can definitely reach out to you and put you in touch with the right people. I can certainly do that. And it looks like I'm just looking at who. Oh, that was you, Teresa, that reached. Okay, there you go. So your question was, are there minimum accident insurance protocols for the owners of the structures versus the ship owners?
Yep.
Larry Dalton, I think you're on here. Would you have an idea what we have at our locks for insurance protocols? I can give you an example on that one. I know at Lock and Dam 2 on the Mississippi River, we had a barge that actually crashed into our guide wall. It took out a huge chunk of the guide wall. And what ended up happening on the legal side of things is that, the shipping company, that, the owner of the barge, they ended up paying for that, the cost to repair that. I think that's getting to the point of where you're, so a lot of our structures, in the Corps of Engineers anyway, they're public, facilities, if you will. I don't know if that helps answer that, but I don't think that we've got insurance at least at our sites in the Corps of Engineers. I mean, somebody can help me out on that one. But the ship owners definitely have to.
This is Larry Dalton. I guess I've always heard that the government is self-insured, if you will.
Right.
You know, that we don't have insurance. And, that's the approach. We find out who did it and go after them. How successful we are in getting money, I'm not so sure.
Yeah.
Over.
Yeah, thanks, Larry. I do know at that one at Lock and Dam 2 that we went after the barge company, if you will, and I think we did recoup some money on that one. But if there's anybody online that could add more to that, please do.
Well, Tim, we had a impact on the gate at Racine. I know for that what I was told is we fixed it out of our pocket and then send a bill to the barge company.
Yep. And then the lawyers got involved, right?
Yeah.
Yeah. Yep. Okay.
And we have received some additional input about collaboration and sharing of information in the chat panel. Biocidal USA's Board of Inquiry reports are not public, but the U.S. Coast Guard investigates marine accidents, and those reports are public.
Yes. And one thing I wasn't totally clear on, and somebody can help me out here, but I do know that the National Transportation Safety Board in the United States investigates quite a few of these accidents on waterways, but the Coast Guard also has a role in there. And so there's obviously a lot of collaboration between the Coast Guard and the National Transportation. And as for who has the lead, I think it depends on the severity of the accident and things like that. I don't have an exact answer on that. If somebody could help me out, but the Coast Guard definitely has a role to play.
Yep. Okay. One question we have about the report. You mentioned the accident rate is going up. Did you graph or otherwise calculate the rate at which accidents are occurring?
We did not do that. Just like I said, one of the things that, at least in the United States, we did look at the National Transportation Safety Board reports. They've got reports going back about 13 years. And then, it seems like a lot of these accidents that happened, like back in the 60s, 70s, 80s, you can't find anything. I mean, it's, so, I mean, to actually trend this, it gets really, really hard. So maybe with all the social media stuff and everything nowadays, maybe we're just paying more attention to when things happen. So there's also a lot more traffic, I mean, So I mean, the more traffic there is, the more chances for things to happen. But no, the answer, we did not trend that.
Okay. And another question on information sharing. Has there been an effort, or is it feasible to get these learnings to inland waterway users, such as vessel operators, or any other preventative types of measures?
Yeah, let me take a look at that question just so I can hold on, Teresa. Let me just look at that here. Let me scroll down here.
Yep.
Yeah, so that was one of the things. This is from Roger, right?
Yep.
Yeah, so this was a takeaway from our report. So you're talking the users themselves, so like the barge operators and the shipping industry, right? I think so, but I know this report was at least an attempt to get that way, to our users, and how we collaborate, between, Larry, I know you're on here, so I'm putting you on the spot again, but I don't have a good answer of what we do, from the core side, working with the inland waterway users. I don't know, maybe Larry, you can help me out on that question, what we can do to help prevent accidents and things like that. Do you know of anything that we've done? You might have lost me.
To literally help not have the accident.
Yeah, I mean, just, what are some of the safety protocols that we have in place? I know the Panama Canal, I mean, and John, if you're on here, they actually take over the ship as it comes through the lock. We certainly don't do that. They actually get on the ship and actually bring it through the lock chamber. That's what the Panama Canal does. But
Yeah.
what collaboration we do, with the waterway users, and improve safety on the waterway, I guess is the question here.
Yeah. So I guess myself, I can't claim to have experience everywhere. Just kind of the parts of the river I'm aware of. I guess not a lot comes to mind. I know that some of the protocols at a lock, like, hey, the barge has to come and stop at this point right here. That they make them stop. Is kind of part of making sure it's safe. So the different projects have different procedural requirements that the word gets out on that. I'm aware of that.
Yeah.
As far as outside the chamber, like in the channel and things like that, I'm not as up on. But at one point we had, the IMTS. There seemed to be a lot of coordination. Maybe 7 or 8 years ago with the Corps, and I guess it seems like there hadn't been as much of that here lately. With different topics and things that they put working groups together and things like that. But just stuff like that's the only thing I'm aware of. Just kind of the processing procedures at the sites. Over.
Yep. Thanks, Larry. I do know, like at that John Day lock, when that ship went underneath the gate, they actually installed better markings and things like that. So there was a collaborative effort going on to actually improve the safety at that lock. Just real quick, and Teresa, I'm thinking you're going to save this chat, and we'll try to address a lot of these, right? That's what we're going to, I think so.
Yes.
Yes.
2 minutes left for questions.
Yeah, what I can try to do is I can try to address a lot of these further. I'm going to save the chat here too. I do see the question about the ship arresters. One of the problems on the inland navigation locks in the United States is that we don't have a good ship arrestor system for these barges. That's something we've tried to look at, but right now, as it stands, we don't have a good ship arrestor system for barges. We do have one for vessels, for ships that go through the Sulaks and go through the Welland Canal and the Seaway and all that. And certainly they have quite a few of these in Europe. So that's part of the issue. The other question that I see here is from the Dolphin, and we got some structural engineers, so maybe they can address this one in the chat. What kind of dolphin can protect against an object weighing 116,000 tons? That's the Baltimore Bridge at 8 knots. That's a lot of kinetic energy. So I'll let the structure answer that one. Board of Investigation reports in the USACE are not public, so thank you. I guess we see one from Rob here. What do you see as the path forward for improving root cause investigations of incidents and collection of data? I think in the core, we could, I know we have Board of Investigations, but a lot of times this information doesn't get passed around. So, I mean, this report was at least an attempt, you know, to highlight some of the issues here. And we need to do a better job of lessons learned, I think. I try. So I'm just looking at the other ones here. Like I said, what I'm going to try to do is address some of these in the chat here. You know, I'll try to get that out to everybody, and maybe Teresa, you can help me with that.
Okay. Yeah, that sounds great. I'm going to push us ahead into our closeout side just so that we can end at the top of the hour. If folks have the time and are interested in sticking around afterwards to keep the discussion going, I encourage you to do so. And like Timothy said, he's going to jump in and start answering some of these questions in the chat. While he's doing that, I'm going to push us ahead into our event closeout. So everyone who attended today is eligible for 1 PDH for their attendance, and you can find that at PIANC.us/PDH with the case-sensitive password accident. And our team will be dropping that into the chat here pretty soon as well. I'll also ask, we do really appreciate your feedback. We always take every opportunity to improve these webinars. And so we'll be circulating a webinar evaluation form. You can also find that in the chat. Thank you, Patrick. Again, we really appreciate your input on today's event. And like I mentioned at the top of the hour, we'll be sharing a recording of today's event via email at the beginning of next week. And that's all of our closeout information. Thank you again for joining us today to learn about crisis management of accidents. Again, we'll be sticking around to answer some questions in the chat panel. If you have time, we encourage you to do so. Otherwise, thank you so much for joining, and I hope you have a great day.
Yeah, thank you, everybody. Appreciate it.